Weight. A tennis ball has a rubber core covered with nylon or wool filled with air to pressurize it. When weight equals mg, with the mass of a standard tennis ball at 0.056 kilograms, acceleration due to gravity equaling 9.8 meters per second squared, the weight of the average tennis ball is equal to 0.056 kilograms times 9.8 meters per second squared. This is equal to 0.54 newtons. Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. A tennis ball will continue to move unless a player hits it with his or her racket. Outside forces acting on the path of a tennis ball include gravity, which pulls the ball down to the ground, air resistance, which slows the ball down, friction, which slows the ball down after hitting the ground, and a racket, which is an external force that changes the direction of the motion of the ball upon impact. Friction. The speed of the game depends on the surface in which it is played on. With clay, it has a larger coefficient of friction, which slows the tennis ball down. Grass, which has a smaller coefficient of friction, because grass is wet and slippery, means that the ball does not slow down as much. Here, there is an example that is shown in the picture. This drop in speed is due to the difference in the coefficient of frictions of the different surfaces. Newton's second law. Newton's second law of motion states that the acceleration of an object is produced by a net force which is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. F equals ma. This means that the amount of force a player hits the tennis ball with causes the ball to move at a certain acceleration. The acceleration can be calculated by the following equation: change in velocity divided by time. Here is an example. 30 meters per second is the average velocity for a tennis ball for women. 30 meters per second divided by 3 seconds is equal to 10 meters per second squared, which is the acceleration of the tennis ball. The average mass of a tennis ball is equal to 0.4 kilograms. Using F equals ma, the force equals 0.4 kilograms times 10 meters per second squared, which equals 4 newtons of force applied. Newton's third law. For every action, there is an equal and opposite reaction. An example would be wall ball. When the ball hits the wall, it exerts a force on the wall, and the wall then produces an equal force in the opposite direction that pushes the ball back. Another example of Newton's third law would be volleys. The impact created by the ball on the tennis racket strings will equally produce the same amount of force, and the ball will bounce back with little effort. Waves and oscillations. When you hit a ball, the racket's waves can be heard, seen, or felt in their vibrations. A node is a minimum vibration, and the center of percussion is the lowest shock point. There is potential energy before a serve, before a hit, and in the serve. There is elastic potential energy in the strings of the tennis racket, which is transformed into kinetic energy when the ball bounces off of the racket. There is kinetic energy after hitting and after serving. Motion include topspin, backspin, drop shots, and slices. The amount of spin depends on a whole bunch of factors, including the speed, spin, and angle of the incident ball, the speed, approach angle, and tilt of the racket, the type of string, etc. Friction that results when the racket brushes over the ball produces the spin. Topspin. The friction that occurs when the tennis racket brushes over the top of the ball produces the topspin of the ball. A backspin shot is hit by sliding the racket underneath the ball as it is struck. When compared to using topspin, backspin requires only 1/2 the racket speed because the player is not required to change the direction in which the ball is spinning. Drop shots. A drop shot is a type of backspin shot where the ball slows down severely. Center of mass. The racket rotates about the center of mass when the ball makes contact with the strings, which is shown in the picture. This is close to the best bounce spot. Projectile motion. When the ball is hit, it follows the path of a projectile. One example would be a lob. A moving tennis ball has a non-zero momentum. When a tennis player hits a tennis ball with his or her racket, he or she exerts a force onto the tennis ball, which changes the direction of its momentum to return it over the net. Examples would be serving before and after, and hitting before and after. Another example would be wall ball. Impulse is being applied when you swing the racket and the tennis ball is hit. In order to increase the momentum of a tennis ball in a serve, the impulse force of the racket needs to be increased. The easiest way to increase the momentum of a tennis ball is to increase the acceleration of the racket before it makes contact with the ball. This also means increasing the speed of the torso and arms. This allows faster movement of the racket. The greater acceleration of the racket during the wind-up stage, the greater the force in which it's applied when connecting with the ball. This will in turn increase the momentum of the tennis ball and increase the speed of the ball. Having a heavier racket will also increase the impulse, F equals ma. The racket with a greater mass generally means more power for the player when they execute strokes. Conservation of momentum means that the momentum before the collision equals momentum after collision. Using the equation momentum equals mv, the mass of the ball times the velocity of the ball plus the mass of the racket times the velocity of the racket equals the mass of the ball times the velocity of the ball after collision plus mass of racket times the velocity of the racket after collision, because of the conservation of momentum. Angular momentum. In the windup of the serve, the rotation of the legs, hips, butt, and shoulders produce the maximum angular momentum. A collision equals a short interaction between two things. An example is between a ball and the racket in tennis. It's quick but not instantaneous. One side of the ball flattens upon impact, and it takes time to compress the ball and more time for it to re-expand as it leaves the racket.